This is the implementation of 555 timer IC. Here we have the feedback circuit. 555 timer IC works on a feedback circuit. This is our feedback circuit. This is a flip-flop, and these circuit contains the comparators. And here we have our output driver circuit, as we can have higher loads which are loading my IC. So this output driver makes sure that the IC is not overloaded, and it will be able to drive the output load. And we have made an application using this, showing that our timer works. So here is the voltage doubler circuit. This is our comparator circuit, in which we have 3 5K resistors. So my voltage is divided into 3 parts. Here we have 3.3, which is 2/3 of 5, and here we have 1.6 volts. So these are the threshold values which we are using in these comparators to compare the voltage across this capacitor. So the capacitor is charging and discharging. It's like when initially my capacitor charges 0, so it is less than 1.6, so this op-amp will turn on. If my voltage across capacitor is less than 1.6, this will turn on, and if it is more than 3.3, this will give 1 as an output. So as initially it is 0, this will give output as 1, and then when it charges and go to 3.3, more than 3.3, this will give 1, and then the circuit charger and the voltage across capacitor decreases as capacitor discharges. So here we have flip-flop, which is SR flip-flop, which we have used NAND gates to make, which we made using MOSFETs, and the clock is always 1 for this circuit. So this is the R and this is the S. This is Q, which is my output, which gives the pulse of my timer IC, and this is my Q dash, which I'll use for the feedback circuit. So as we saw, we have comparators. So this is the voltage across the capacitor, and this is the threshold. So let's assume when the voltage across that capacitor is more than 3.3, then this will be 1. So that is 1, that red line is 1. So my output will be, my Q dash will be 1 here. So my Q dash went to 1 as soon as I got a pulse there. As soon as I got a pulse there, and my Q will be the other way around, because my S is 0 at that point. And when the voltage across capacitor is less than 1.6, this is the threshold value, so less than 1.6, then this will give 1, as we can see in this. And as this has given 1, my Q will be 1 at this point. My Q is 1 at this point, and my Q dash will go to 0. So here, as we can see, we have got 2 pulses, which is Q and Q dash, which are complementing each other. The voltage level 3 is my Q, which is the dark green one. And here, as we can see, this green one is my Q output, and this is my Q dash of the flip-flop. So this is my output pulse of the timer. So here, this is Q. So initially the Q was 1, which is 5 volts. So here my base voltage is also 5. So the voltage difference between base and the emitter is 0. So this transistor will be off. So here there will be a 0. So as here it is a 0, I have this feedback circuit. So here it is 0, and then again the voltage difference between base and the emitter is 0. So this transistor is off. So there is a connection between 5 volts to capacitor. So capacitor starts charging from there. So here capacitor started charging till it was 3.3, and then this will give 1. So then my output will change to 0 here. So if my output is 0 here, if my Q is 0 and my Q dash is 1, so as my Q is 0, as my Q is 0, there is a voltage difference, so VB is greater than 0.7. So here, so as we see here, this is my Q dash, which is 1, so this transistor is on. So current will flow from here, there will be a little drop from here, but here current will flow, and here the voltage will be more than 0, so it will be around 700 millivolts. That's how the resistors are calculated and kept. So again, when this feedback circuits go into this, so we have make sure that the VB is greater than 0.7 for this NPN. So there is a connection from this ground to capacitor. So the capacitor starts discharging when my Q is 0. So it starts discharging, and when it is less than 1.6, this op amp will give 1, and then my output changes to 1 again. So this is the output driver circuit. Here I have Q coming, and here this is the Q dash from my flip-flop. So my output should be same as this Q. So when this Q is 1, here as I've told earlier, this will be around 0, and when it is 0, it will be around 700 millivolts, something like that. And then Q follows the same values as this. So when this Q dash is 1, this transistor is on, so current flows from this, there is a voltage drop from this, so that there is a voltage difference between this, so this transistor turns on. So when this transistor turns on, current flows from here to here, and there is a voltage difference between this right now because of this resistor, so the current flows from here. And as I have, this is my external voltage driver circuit, so let's take it as if we see an input impedance from here and consider this as a resistor, here the current flows from VCC, so the voltage will be charged here. This is to demonstrate my output after the voltage, output driver circuit, that I have a pulse from 0 to 4 volts, which is almost equal to VCC, and my current is also equal to 400 milliampere, which is enough to drive my output if I have heavy loads. So then next we will, as we can see, my output voltage is equal to 8.2 because this diodes are not ideal. So because of the cutoff voltage, there is a drop of 1 volt here and 1 volt here, as the cutoff voltage for this is 1 volt. So this is a capacitor which is used to provide the extra charge when my output driver circuit is not able to give it the charge that is required to charge.
This is 555 timer. In this we had a comparator and a flip-flop. Before comparator we had 3 5K resistors connected between 0 and 5. Here we had 0, here we have 5 voltage. Here we get 1 by 3 5 voltage, that is 1.6, and here we get 3.3 voltage. These were connected to 2 op amps. For this op amp, 3.2 was connected. If the another pin was higher than 3.2, then the output could be 1. Here, if we had the another pin connected voltage less than 1.6, then it would be 1. Initially, we had 0 voltage across capacitor. So by taking reference values from here and here to op amp, so we had 0 voltage across capacitor. So this would be inputs were less than 3.3, so this would be 0 and this would be 1. This is R and this is S. So these were connected to flip-flop. So the output of the flip-flop, that is Q dash, it is R, so this would be Q dash, so this would be 0. So after this we had NPN, so NPN is off, so we had 5 voltage from here to here, so capacitor will charge. Then we had 5 voltage across capacitor, so it is greater than 3.3, so the R would be 1 and S would be 0. So after that we had R1, so output of that R is 1, so NPN will be on, and we had connected 0 directly in between these two resistors through NPN, so capacitor will discharge. Our circuit with actual 555 timer IC, we had operated both in a stable mode. So we are having R1 as 1K, R2 as 10K and C1 as 0.1 micro. With our circuit we are getting time period as 1.42 milliseconds. With 555 timer IC we are getting 1.49, which is almost same, and 55% as duty cycle with our circuit, and with 555 timer IC we are getting duty cycle as 51%. And then R1, and then we are having R1 as 1K, R2 as 1K and C1 as 0.01 micro. With our circuit we are getting time period as 21 micro, duty cycle is 76%. With actual 555 timer IC we are getting time period as 22 microseconds, which is almost same to equal to 24 microseconds. We are having R1 as 1K, R2 as 10K and C1 is 0.01 micro. With our circuit we are getting 147 microseconds. With actual 555 timer IC we are getting 148 microseconds, which is almost same. And then we are having R1 as 1K, R2 as 10K and C1 as 1 mu. With our circuit we are getting time period as 13 milliseconds. With actual 555 timer IC we are getting time period as 15 milliseconds, which is almost same. And then we are having R1 as 1K, R2 as 10K and C1 as 100 micro. With our circuit we are getting time period as 11.2 seconds. With actual 555 timer IC we are getting time period as 13 seconds, which is almost same. And then we are having R1 as 1K, R2 as 10K and C1 as 47 micro. With our circuit we are getting time period as 530 milliseconds. With actual 555 timer IC we are getting 676 milliseconds and duty cycle 55 for our circuit, and for 555 timer IC we are getting duty cycle as 51%, which is almost same.